So how I'm going to, you can say, recommend the movies. Okay, because we have generated some kinds of tags, okay, some kinds of, you can say, paragraph here. And now what should be our approach? Okay, so that the model can identify the similar kinds of content. Okay, so for that I will be give you you can say brief overview of our, you can say, project workflow, what I'm going to do here. So okay, so let me go to my blackboard. So guys, as you have already seen, we have generated tags here. Okay, you can say uh, we have combined all the information, all the keywords, genres, okay, then grew information in a tags. And now we have a, you can say, big paragraph. Okay, paragraph. Okay, so by using this big paragraph, I will be, you can say, generating some kinds of, you can say, vectors. Okay, because I cannot use this textual data set directly in my problem. Okay, at the end I have to convert it to a numbers. Okay, so for that, what I can do, I will just perform counter vectorizer here. Okay, so I think you have heard of this counter vectorizer. So what counter vectorizer actually do? Okay, so I'll be show you. So counter vectorizer, actually we have, you can say, almost 4806 you can say rows. Okay, that means records in our data set. So in this you can say 4806 rows. Okay, it will it will combine all the tags together. Okay, suppose I have, you can say, 4806 tags. Okay, that means paragraphs, okay, are presented in my data set. So what it will do, it will combine all the 4018 tags together, and it will, you can say, generate a big, you can say, big composition. Okay, big composition, or you can say big, you can say, paragraph. Okay, so because it will, you can say, use all the, you can say, uh, tags, okay, from my this 4806 information. And now if I pass it to my counter vectorizer, counter, so what it will do, it will identify some kinds of unique work, like actors. Okay, then you can say uh, some of the actors name. Okay, names. Then you can say so let me show you. So see, this is my paragraph. So from here it will, what it will do, it will just identify some kinds of unique word. Okay, in counter vectorizer it will identify some kinds of unique word, like century, then this paraplegic, okay, then marine, then dispatched. Okay, so these are the some information it will, you can say, it will be taking. And what it will do, it will be it will generate, you can say, it will generate almost, you can say, 5000 5000 you can say columns. Okay, because I'll be considering you can say most frequent 5000 words. Okay, from this paragraph itself. Okay, so that's why you can also increase that size also, it based on your experiment. Okay, so but I have seen if you take just 5000, you can say, most frequent word, so it will perform good in this case. Okay, so I'll be just taking 5000 most frequent you can say words, and I'll be performing the counter vectorizer. Then what it will do, suppose it has, like, you can say, taken all the frequent you can say word from this paragraph, and now it will compare with this now you can say it will compare with this 4806, okay, information. Okay, suppose it will take the first one, then it will, you can say, compare with these tags, and it will just identify how many times this you can say how many times this, you can say, action has, you can say, occurred in this data set. Okay, suppose action has occurred 2 times, then name has occurred, you can say, 3 times, then you can say others information has occurred, you can say, almost 6 times. Okay, so like that it will generate one, you can say, vector here, vector. Okay, like that it will take another second information, and it will perform the same things. Okay, uh, it will like identify how many times the action are like presented. Okay, so suppose 3 times, now it is 2 times, and it is, you can say, 8 times. Okay, so like that, it is vector 2. Okay, vector 2. So now I can say I have the vector. Okay, so now I can say I have the vector. I have the vectors. Now I can, you can say, plot this vector in a, you can say, a dimension. Okay, in a uh, you can say n dimensional space. Okay, I can plot that. So here, suppose just consider 2D dimension, because more than, you can say, 2D I cannot show you. So just consider 2D dimension. And suppose here I got, you can say, all of my vector. Suppose after performing this counter vectorizer, I have, you can say, 4806 vectors. Okay, vectors are presented, and the column is like, you can say, 500 5000. Okay, because I have considered the 5000, you can say, uh, rows. Okay, 5000 words. Okay, so now if I you can say plot all the vectors here. Okay, so let me change the color. So if I suppose plot all the vectors here, so this is one of the vector, this is one of the vector, then this is one of the vector, this is one of the vector. Okay, suppose I have plotted all the vectors like that. Okay, and now let's say you choose that vector. Okay, you choose that vector as a movie. So what I will do, I will just, you can say, find the, you can say, uh, less distance of the similar kinds of vector. Okay, here suppose I can say this is, you can say, very near to this, you can say, vector, and this is also near to this vector. Okay, then I can consider these two movies. Okay, these two movies, similar kinds of movie, similar similar movies. Okay, so similar, you can say, similar kinds of, you can say, movies. So I can consider uh, like that. I will be, you can say, taking all the recommendation. Okay, in a you can say vector space. Okay, I'll be plotting all the vectors, and if user gives any kinds of, you can say, movies. Okay, then I will be just, you can say, measuring the cosine similarity. That means here I cannot, like, you can say, perform this Euclidean distance. Okay, Euclidean distance, I will not, you can say, perform Euclidean distance. I'm not going to perform because if I show you, okay, so it's a kinds of, you can say, 5000 dimension here. Okay, so in the higher dimension, okay, so if you perform this Euclidean distance, okay, so it will fail sometimes. Okay, so it is not recommended. But if you use this cosine similarity, cosine similarity, so I think you know the cosine similarity. What it does, it just try to, you can say, figure out the you can say angle between two vector. Okay, so suppose this is theta, this is one vector, vector 1, and this is vector 2. Okay, it will just measure this angle between them. So the less angle it will be, this less distance, you can say, the higher, you can say, similarity will be between these two vectors. Okay, so I'll be performing this cosine similarity between all the vectors. Okay, I'll be measuring all the vectors, then I'll be picking up those information, okay, which are related to ours, you can say, nearest vector, you can say. Okay, then I'll be considering top 5, you can say, movies. Okay, as per our, you can say, recommendation movies. Okay, so this was you can say, whole architecture, whole, you can say, workflow of our projects. Okay, now let's implement that. So guys, I have shown you the workflow. So what I'm going to do, okay, so for that, first of all, I need to fix one things here. Okay, so if you see the sentence, okay, if you see some of the sentence, so you'll be seeing there would be some kinds of, you can say, similar kinds of words. Okay, like actions. Okay, so if you see the action, so this is actions, and here you will also find, you can say, actions. Okay, like including s. Okay, so action and actions is this, I can say, these are similar kinds of word, uh, but they're occurring different, you can say, times. Okay, different, you can say, one is containing, you can say, without, one is contains, you can say, s, and one is not containing s. Okay, so this is the problem. So like that, like there would be a lots of word like love. Okay, love, and you will finding like some of places, okay, loving or loved, okay. So these are the same meanings, but this you can say words are different, okay. So that is the issue. So for that we can you can say use stem, okay. So if we perform the stemmer here, so we can solve that issue, okay. So what stemmer will do, so let me show you. uh, so stemmer will do, okay, suppose you have three words, okay, love, then loved, then loving, okay. Suppose these are three words you have. So if you perform the stem operation here, so what it will do, it will just you can say convert it to love, okay. Convert it to love, because these are you can say containing the same meanings, okay. So I don't need that. If I have the love only, okay, so I can consider you can say it is you can say expressing the same meaning, okay. So this will perform the stem operation here, okay. So for that, like I'll be using the NLTK library. So here I'll be importing NLTK, uh, sorry, NLTK. uh, it might not be installed in your system, okay. So for installing, just do pip install NLTK, okay. It will install in your you can say environment, but I have this already, so I'm not going to install now. I'll be you can say importing this team, okay. There is a you can say class called poster steam porter steamer, so, okay. So I'll be importing that. So I'll write from NLTK dot steam, then I'll be import this porter steamer, then I'll be creating an object porter steamer, okay. Now I'll be you can say creating a function, okay. So if I pass my text here, so it will you can say handle this problem, okay. So like that I will be creating a function called steams, and it will accept a text, then you can say uh, it will you can say store all the information in this list, okay, at the end. So now I will be performing a for loop for I in text dot split, okay, because I have to split it to a words first of all, okay. Then I'll be performing this you can say rel dot append, okay. Because I'll be appending all my fixed you can say words, okay. That means I'm performing this steam operation, and after performing this steam operation I'm appending to my list, okay. So this is the things I'm writing, and at that I'll be returning my you can say paragraph again, okay. Now let me join this you can say L, okay. Yeah, L. So this is the helper function, it will do my job, okay. So here what I'm trying to do, first of all I'm you can say converting this paragraph to you can say list of the word, and this list of the word I'm passing to my you can say porter steamer, and poster steamer are solving this kinds of problem, and after solving it is you can say appending the information to this list, okay. Then I'm converting it to again to the paragraph, okay. So this is the things it is performing. So now if I perform that in my new df my steams function here, and if I run that, so it will take some time because it will identify each and every words, okay, and it will perform the steam operation on top of that. So I'll be waiting. So guys, it has done the operation. So if I show you the you can say iloc first one, and if I show you tags, so see now it has like done some of the changes, okay. So if you compare with others, okay, so you can see some of the changes has done, like if I show you, see unique, but first of all it was kinds of unique, okay, E. But if you don't give the E, okay, so that is also fine, okay, because these are some, you can say, advanced technique. So you can learn it, okay. There is a documentation, so you can learn it about streams, okay, how it performs. But if you perform that, so see, there is a romance, okay, was a romance, but it has been romance, okay, but it is containing the same meanings, okay. So these are some, you can say, specific transformation is done, okay. Now I can say our text is ready, okay, ready to use. Now I'll be, you can say, convert it to counter vectorizer, okay. I'll perform the counter vectorizer. For that I'll be writing from scalar, okay. From the scalar I will be importing the counter vectorizer. So feature extraction dot text import counter vectorizer. Then I'll be creating an object called cv, then counter vectorizer, and I'll be mentioning my max features. That means I'll be considering 5,000 features, okay. 5,000 most, you can say, frequent words, okay. I'll be, you can say, considering. So here I'll be mention 5,000. And stop words, okay. Here I have to also remove the stop words, okay. Stop words means like, if you see the in, then the, okay, then this is, okay. So these are the, you can say, some of the words, okay. Some of the uh, they are not, you can say, expressing the meanings, okay, in this sentence. So I'll be, you can say, dropping that information from here, okay. I just need the meaningful words, okay, from this sentence. So that's why I'm reviewing the stop words. So stop words means like, here we are using the English language, so I'll be mentioning the uh, English. So it will just, you can say, get rid of this kinds of in, a, then is, okay. So this kinds of unmeaningful information from here, okay. So if I run that, now let's perform our vector. So it is, I'll be, you can see, storing in my vector um, variables, then cv dot fit transform. Then I'll be mentioning my tags here. So new df, if I give the tags, then after performing that, I will be, you can say, converting to array, okay, because it will give you a sparse matrix, okay, but I will be converting to to an array, okay. So if I do that, so I'll be getting my vector. So if I show you the vectors, so guys, see, this is the vectors, like I have generated. And if you see the shape of this vector shape, you see it is 4806, okay, rows information, and 5,000, you can say, columns are available, okay. So what are the things I have discussed here, okay. So you'll be finding the similar kinds of things here, okay. So now I have the vectors, okay, and now I can easily measure the cosine similarity, okay. So now how can I do that? So for that, like, I will be, you can say, importing the cosine similarity from the sklearn. So from sklearn, then matrices, then you can say pairwise. In the pairwise import cosine similarity, okay, cosine similarity, okay, sklearn, yeah, cosine similarity. Then I'll be uh, creating an variable here, okay, an object here, similarity, for similarity. Then I'll define my cosine similarity here, cosine similarity. Then I'll be passing my vectors, okay. So it will give me all the, you can say, similarity score, okay. Then if I show you the similarity here, so yes, so these are the similarity, okay, I got. So how it is done, okay. So it is the first you can say vector similarity scores. Okay, so if you see this this is 1. Okay, that means this is the first vectors. Okay, and it is like measuring the cosine similarity with the same vectors. Okay, so that's why it is 1. Okay, and then it is like checking with the second vectors, then third vectors, then fourth vectors. Okay, then fifth vectors. Okay, like that it is checking all the you can say 4806 vectors. Okay, so if I show you the similarity shape, similarity dot shape here, so you'll be seeing see it's a kinds of 4806 and 4806. Okay, dimension, because it is you can say measuring all the you can say 4806 vectors. Okay, with each other, so that's why it is giving the scores. Okay, and these are some scores. Okay, now we can use that scores. Okay, for you can say recommending our movies. Okay, so now how we're gonna recommend. So guys, now we have our similarity score. Okay, and now we can you can say get our similar kinds of movie from the similarity score. So for that, first of all I will need our you can say movie index. Okay, so how we can you can say get the movie index. Okay, so first of all I will be show you. So here if you just write new df. Okay, in the new df you can say if you want to filter out your index, because it will help me to identify our title. Okay, our index of the movie, so that like we can use it later. Title and equal to you can say suppose I'm giving you Spider-Man. I know Spider-Man is there. Spider-Man. So now if I do index, okay, and if I just fetch the first information, so see Spider-Man you can say movies is presented in the 159th number index. Okay, so by that like I can calculate my index. Okay, and I can get my movie from here. So I'll be you can say creating a function here. Okay, so called recommend, so it will recommend the movie. Okay, so I'll be creating this function and it will take a new movie you can say from the user. And first of all it will identify the index. Okay, index of this movie in our database. Okay, in our this you can say this database, what are the data we have. First of all it will identify the index of that movie. So I can you can say write the same code. Okay, for identifying our you can say movies. Okay, so in this Spider-Man, here I have to write the movie, because user might give any movie. Then I'll be you can say uh, finding the index. So after getting the index I'll be you can say checking the distances. Okay, distances of this movie with the other movie. Okay, so if it is like similar. Okay, so so I'll be just measuring the distance. Okay, so what are the similar kinds of movie are available, okay, with respect to this movie. So I'll be taking as a recommendation. Okay, for my recommendation engine. Okay, so here I'll be doing sorted operation, because as you can see it is you can say not you can say, because you can see it is not a sorted. Okay, it has like you can say uh, this all the information you can say are sorted in a random way. Okay, so I have to sort that first of all. So I'll be sorting it. Uh, but if I sort that, so I'll be losing my you can say index information here. Okay, so for keeping my you can say index information safe, so I'll be performing the enumerate operation. Okay, so in the list itself, okay, I'll be performing the enumerate. Okay, enumerate. Then I'll be passing my similarity. Okay, so what are the similarity we are getting from here. I'll be passing my similarity, and from the similarity itself I'll be you can say taking my index. Okay, so what are the index user is giving. And then if I after getting that I'll be you can say do reverse. Okay, reverse is equal to true, because I just want to you can say uh, sort in a reverse way. Okay, so that's why I'm performing that. Then I have to also perform it uh, Okay, so I have to also, you can say, do it on my keys. Okay, because if you see enumerate, what it will do, so if you perform enumerate, okay, on top of a list, suppose it is a list. Okay, I have a list 1 2 3 4. Okay, and if you perform the enumerate, so it will generate an index like 1, then 2, then there would be another list, you can say 3 5 0. Okay, then 3, then you can say 6 7 8. Okay, so these are some index, you can say, it will be generating whenever you perform enumerate. Okay, but if I don't mention the key, okay, if I don't mention the key, so it will sort the value based on this index value. Okay, but I don't want that. I just want to sort this value based on my second, you can say, score, because it is my, you can say, similarity score. Okay, so if I show you, this is my similarity score, and based on that I want to, you can say, uh, sort my value. Okay, so that's why I have to mention the key also. So here key is equal to, I'll be writing that this line of code. Okay, so it will like do my job. Okay, so it will take my one by one this vector. Okay, with this enumerate vector, and it will identify this, you can say, similarity score, then it will sort that. Okay, it will sort that. Okay, and what are the, you can say, sorted value I'll be getting. So I'll perform a for loop here for I in distance. Okay, so I just want to take, you can say, 5 movies. Okay, what are the movies has, you can say, the highest similarity, okay, with respect to the user given movie. Okay, so I'll measuring that. uh, so I just want to take the top 5 movies. So here I will be just, you can say, mention 1 2 6. Okay, it will give me top 5 movies, and I'll be printing that movies here. So new df dot highlock. Then if I show your my eye, I just want this first, you can say, information. That's why I mentioned this 0. And if I just want the title. Okay, title of the movie. So if I write the title, so I think yeah, that will do my job. Okay, so if I pass any movies right now, suppose I'll pass, if I call my function, and suppose I will pass Spider-Man. So let's see it is recommend or not. So if I pass Spider-Man, so see, it is giving similar kinds of, you can say, recommendation. Okay, so yes, I think it is working good. Let me see some of the movie, the Dark Knight Rises. Let me give that here. See, if I give the Dark Knight Rises, okay, so all the movie related to this Dark Knight, okay, Batman related, so it is like recommending. Okay, so yes, I think we have done our, you can say, model. Okay, here I'm not using any machine learning algorithm, because it's a kinds of, you can say, a recommendation engine. Okay, so if you find similarity kinds of content, okay, so you can easily recommend that, so you don't have to train the model. Okay, so here I'll be generating some of the embedding, so that like I can use it later. Okay, whenever I will be implementing the web application. Okay, so that's why I'll be saving two, in you can say, necessary information. So one is like our similarity score. Okay, I'll be saving in a pickle format. Then I'll be saving also this, you can say, movie list. Okay, so what are the movie list I have. So see, these are the movie list. So I'll be also saving in a pickle format, so that I can use it in a later. Okay, so I'll be import my pickle. Then I'll be writing pickle dot dump. Okay, pickle dot dump. Then I'll be mentioning my new df, because first of all I want to, you can say, dump my new df, because I'll be you can see, using the movie titles here from here. Okay, because in the teaser itself, you have seen I'm, you can say, rendering the movie name as well. Okay, on top of the poster. Okay, so that's why I will be using that. So here I'll open a folder called artifacts. Okay, and in the artifacts I'll be saving it movie underscore list dot pickle pkl. Okay, pickle. And I'll be mentioning the read write binary mode, okay, because I'm writing. And similar wise, I'll also save my similarity score here. So pickle the dump, here I'll be mentioning the similarity and artifacts, and here I'll be mentioning similarity pickle. Okay, so now if I hit enter, okay, so it is giving me some error. So guys, it is showing you error because there is no artifacts folder, so you have to create the artifacts folder here. So if you create that, and now if you run that code, okay, I think that should work. Yes, it has done. Now if you go to your folder, okay, artifacts folder, now you can see all are your embedding. Okay, so now you can use that embedding, okay, for recommending your movies. Okay, what are the things like you have performed as of now? So I have saved in a pickle format so that I can use it in a later on. Okay, so yes, this was you can say our whole overflow of the projects. Okay, now in this you can say stage I will be you can say adding the web application. Okay, I'll be you can say creating a web application so that like an user can easily so that an user can easily use that. Okay, then after creating this web application I'll be deploy it on the Heroku, so that like you can also learn how to deploy this kinds of application to the cloud itself. Okay, so let's start implementing our web application.